Yes, welcome to the class, dear students. In the last class, we have done about the definite integrals. Now, in this lecture, I am going to discuss about the improper integrals. What is meant by the improper integral means these are the definite integrals, but for which the range of integrand is not defined. What do you mean by not defined means at that particular point the function is going to infinite, suppose. Then we say that it is an improper integral. So let us have some examples. Integral 0 to infinity f of x dx, suppose. At the point infinity the function will not be defined, right? So that is why it is an improper integral. Not only this, if the lower limit is minus infinity to 0 also it is an improper integral. Not only this, from minus infinity to infinity f of x dx is also an improper integral. Apart from this, you have some other type of improper integrals where the limits of the integral are finite only. But when you take the range of this integration, that is 1 over x minus 1 if you take, and take all the values as the lower limit, the upper limit, and the values between these limits also, if at all you are getting 0, suppose in the denominator, the whole function becomes infinity and it is an improper integral. For example, you take 1 over x minus 1. Now, for which value of x minus 1 it becomes 0? When x is equal to 1, the value becomes 0. Therefore, and that value x equal to 1 lies in this interval 0, 2, correct? In the interval 0, 2, your 1 belongs to 0 and 2. And at this point, the function is not defined. We will find out a discontinuity of this function. So, it is an improper integral. Next, not only this, for example, if you have integral 0 to 2, 1 over x square minus 4 dx is there. Now, if you substitute as x is 2, then it becomes 2 square minus 4 and this becomes a 0. When this becomes 0, it is undefined. You will get a discontinuous function. So, this is also, that means at the upper limit it is not defined. Here in this problem, the point which is in this interval, it is not defined. So, all these are the improper integrals only. So, we can say that the improper integrals are of two types. One is the limits itself, they are infinity like that they may shown. Or type 2 is the range of integrand is infinite. Okay. So, when you do the range, when you see the range that of the integrand, if it is not defined or it is infinite or it is discontinued, then it is called as type 2. Now, in today's lecture, I am going to solve type 1 improper integrals. That means the limits are infinity like this. So, suppose, now what is the strategy we follow here is integral a to infinity f of x dx. It is understood that it is improper, and since the infinity is a limit, it is of type 1. That is what the identification. Now, when the upper limit is infinity, always we write a to b first of all. And the upper limit is b and b goes to infinity. This is what the style of writing the given integral. So, limit b tends to infinity, integral a to b f of x dx is nothing but a to infinity f of x dx. For solving purpose, we will write like this. So, next the function is of course is continuous from a to infinity. Now, suppose if you have minus infinity to b, suppose, then what we write? Again a to b, but a is going to minus infinity. So, we say that again f is continuous from minus infinity to b. And then, if the function f of x dx is minus infinity to infinity is given, suppose, then we have to search for a point which is lying in this interval, a real number which is lying in the interval minus infinity to infinity, and we split this integral into two parts as it is lower limit and this is upper limit. How we have done for 1 and 2 cases, like that we have to rewrite these two and add them. This is what the method or the style of solving the improper integrals of type 1. So, let us now solve the first problem. Suppose integral 1 to infinity dx over x power 3 by 2. So, this is a clear, very much clear that it is infinity. So, it is type 1 of improper integral. So, how do we write this? As integral a to b. Now, in the place of a, you have the limit 1. So, put 1 to b itself and b is going to infinity. Dx over x power 3 by 2. Now it's a normal integration like x power minus 3 by 2 dx you will be solving, and then x power minus 3 by 2 by minus 3 by 2 plus 1, and then substituting the limits from 1 to b. And then as b is going to infinity, you will be solving it as and flipping everything minus 2 times of x power minus half. And when you substitute the limit as x as b power minus half minus lower limit as 1. So then we get b power minus half means 1 over root b minus 1 minus 2 times of this whole thing, where b is goes to infinity. You have to remember one thing here as limit of n tends to infinity 1 over n always goes to 0. Limit n tends to 0, 1 over n goes to infinity. You can remember one thing. If infinity, you will take it as an ocean and a universal, suppose. And 0 means nothing. What is the inverse of the universe? It is nothing. What is the inverse of nothing is the universe. So remember like that. As n goes to infinity in the denominator, the whole value goes to 0. As n goes to 0 in the denominator, the whole value goes to infinity. So this is what you should memorize or understand. So now minus 2 times of 1 over root b minus 1. As b goes to infinity, this infinity is the denominator, so it goes to 0. So it is minus 2 times of minus 1 is equal to 2. So this is what the strategy we have to follow to solve type 1 improper integral. Let us now go to type another problem. From minus 1 to infinity, e raised to minus 5x. Now here also you have to understand one thing. Limit as x goes to infinity, e power minus x goes to 0. Remember that e raised to minus infinity is equal to 0, e raised to infinity is equal to infinity. Actually, if you understand the curve, then it will be easy, but let us see. The curve e raised to x is going to like this, okay? This is the function, this is the curve e raised to x. Now as x goes to infinity, this is x-axis. As x goes to infinity, e raised to x is also going to infinity. As x goes to minus infinity, it is slowly reaching to 0. Did you understand? So as x goes to minus infinity, e raised to minus infinity becomes a 0. And as x goes to infinity, e raised to infinity is infinity. So remember, e power minus infinity is 0. So now let us start this problem. Try to understand. Here, the value of this integral is this. And now what we do? We write e raised to minus 5x integral. And as b is infinity, as the upper limit is infinity, we write this as b minus 1 to b e raised to minus 5x dx. So limit b tends to infinity, normal integration, e power minus 5x by minus 5. The limits are from minus 1 to b. Now, how we have done for the integrals of definite integrals? Upper limit minus the lower limit. Minus 1 over 5 times of e power minus 5b minus e power minus 5 times of minus 1. So that gives you e raised to minus 5b minus e power 5. So that gives you e power 5 by 5. As b goes to infinity, this whole value goes to e power minus infinity. And e power minus infinity is 0. Therefore, the value is e power 5 by 5. So this is what the next second problem. Let us now go to the third one now. Integral minus infinity to infinity dx over 1 plus x square. So now both the limits are infinite. So what we do? We take a point which is in between minus infinity and infinity. So let us take 0 as a real number which is lying between these two. So again, since it is minus infinity and infinity, it is very much clear that it is type 1 of improper integral. So what we have to do now? We have to split this integral as minus infinity to 0 and 0 to infinity dx over 1 plus x square. So now it is minus infinity is in the lower limit. So we write a to 0, a goes to minus infinity, and here infinity is b. So b goes to infinity 0 to b, this one. Now what is dx by 1 plus x square? Is tan inverse x. This is what you should remember. 1 over 1 plus x square is tan inverse x. Within the limits a to 0, again tan inverse x within the limits 0 to b. So put upper limit minus lower limit, tan inverse 0 minus tan inverse a, again tan inverse b minus tan inverse 0. as of course the limits are a to infinity, a is going to minus infinity, b goes to infinity. Now here you should understand these things here. Tan of pi by 2 is infinity, correct? So pi by 2 is tan inverse of infinity. Similarly, tan 0 is 0. So 0 is tan inverse of 0. So similarly, tan inverse of minus infinity, if you take, it is minus pi by 2. So by using all these, you can substitute here. What is tan inverse of 0 is 0 minus tan inverse of a is minus infinity. So tan inverse of minus infinity is what? Minus pi by 2 plus tan inverse of infinity is pi by 2 minus tan inverse of 0 is 0. So it is pi by 2 plus pi by 2 gives you the value pi. Now let us do the last problem. Integral 1 to infinity dx by x. Again it is of type 1 improper. So again upper limit is infinity. So limit b tends to infinity 1 to b dx by x. It is ln x. 1 over x dx is ln x, right? And putting the limits from 1 to b, ln b minus ln 1. Now as b goes to infinity, ln of infinity is infinity. So it is the value of the integral is infinity itself. So with that we have completed improper integral of type 1. In the next lecture we will be doing solving the type 2 improper integrals. I hope you enjoyed the lecture. Thank you.